let's start diving into algebra with a little comic. I don't get it. Algebra was invented thousands of years ago, and x is still unknown. Okay, we're off to Neverland in our discovery of algebra. We're going to start with baby steps, and most of these equations you'll be able to solve in your head. Keep in mind that we're not concerned about the answer at this stage. What we're concerned about is whether or not you have the correct process. Before we get started, let's just think about equation solving in general. Whenever we're solving equations, the object is to get the variable alone. Solve for x, solve for k, solve for q. You're not solving for negative x, you're not solving for x squared, you're not solving for t cubed, you're solving for those variables t equals, q equals, k equals. How do we do that? Well, if we have something that's being added to our variable, we'll subtract the same number. If we have something that's being subtracted, then we'll add that same number. If the variable is being multiplied, we'll divide by the same number. And if the variable is being divided, we'll multiply by the same number. This is called using inverse operations. Now you need to keep in mind two things. When we multiply, divide, add, or subtract, we're doing that to both sides of our equation. That keeps the balance. So let's take an example that I'm sure you already know the answer to, but how do we solve this algebraically? Number 1, x minus 6 equals 15. Well, I have a number that's being subtracted from my variable, so I want to add that same number to both sides, and I call these railroad tracks. You might want to start off with those because they help you keep things on one side or the other. So I know in this case I added 6 to both sides, and x equals 21. Let's go on to number 3. 3y equals 18. So the y is our variable. It's being multiplied by 3, which means I want to divide both sides of my equation by 3. In doing so, on the left side, the 3's cancel. On the right side, I get y equals 6. Number 5. So I give you all these rules and I'm already mixing it up, because if I look at number 5, my variable is m. I'm adding negative 40 to m. So I should be subtracting, but I'm going to tell you, you should be adding. Can you figure out why? The reason why goes back to the fact that if I wanted to get rid of the negative 40, I would subtract negative 40. Well, subtracting negative 40 is the same as adding, and I don't feel like writing all that out, and you probably don't feel like writing all that out either when I know that to get rid of a negative 40, I gotta add a positive 40. So really, I'm not breaking the rules. I'm just abbreviating the rules. So the 40s cancel, and I'm left with m equals 53. Number 7. In this case, I have x minus negative 2/5. Again, I'm going to go ahead and change that right to x plus, because if I left it as subtract negative 2/5, when I said that when you do inverse operations, then I would have to add negative 2/5. Well, I already know that to get rid of that 2/5, I need to add a negative 2/5. So I'm just going to change that, and that way I can add negative 2/5 here and negative 2/5 here, and I'm going to get 13 3/5 equals x. Number 9. X is being divided by 6, so I'm going to multiply each side by 6, and you might want to put that 6 over 1 since that's a fraction, and my 6's cancel out, which leaves me just with x over 1, or x equals 72. Now I'm going to let you do the evens, but keep in mind that you're dividing or multiplying or adding or subtracting the same number, so don't get tricked. Go ahead, try those on your own. A couple tricky ones here and some straightforward ones. If you got 0.8 for number 4, you're not going back and thinking about decimal division. Outside, inside, up. The answer is n equals 8. Remember, I'm dividing by exactly the number that was being multiplied. 6 might have been tricky for some of you because the 13 was on this side. Now, some of you might have gone ahead and used commutative property and said, I know that's k plus 13 equals 45, which you could have done, and then you wouldn't have had to do that kind of sort of backwards look to it. 8 should have been straightforward, and 10. Again, that decimal division and some negatives to be aware of. So we were multiplying by negative 5/100ths, so I have to divide by negative 5/100ths and then do my decimal division correctly. How we doing?
That was easy.
Now we need to talk about checking your answers. Now most of you can check these mental math. It's not a big deal. But when you get into harder equation solving, it's very helpful to check your answers because you can walk out of an algebra test knowing exactly how you did. You might say, I know I got 11 wrong because it didn't check, but I couldn't figure out what I did wrong, okay? When we check our answers, the important part is to rewrite the equation. And we always rewrite the original equation, not what you simplified, because you're going to get into some here where you're going to simplify it first. Don't do the simplified version, because if you made a mistake when you simplified it, then that will check and it's actually wrong. We'll talk about that more when we do more complex equations. So here they show the equation, then they plug back in. This is where our substitution comes into play. I'm substituting in for x and I'm asking the question, does it work? Let's try number 2 together. Easy equation. I add 14 to both sides and I get m equals 15. To check it, I rewrite m minus 14 equals 1. I plug back in my 15 and I ask the question, does that work? Yeah, 1 equals 1. Sure, piece of cake. Don't fudge the checks. I always know if you're trying to make it work and it doesn't work. 5k equals 12.5. So what am I going to do? You got it. Divide by 5 on both sides. When I divide that out, I get k equals 2.5. To check it, I'm going to rewrite the original equation. 5k equal 12.5. Does 5 times 2.5 equal 12.5? Well, if you're not sure and it's some math that you can't do in your head, you better go over and check it. So I'm going to try 5 by 2.5, 5 times 5, 25, carry the 2, 1 decimal place, yes, it checks. Why don't you go ahead and do 4 and 5 on your own? For number 4, I got -7/2. And when I check that, notice how nice it is to have left that in fractional form. Then I can just multiply, the 2's canceled, and so did actually my negatives cancel. Negative times negative is positive. Then in number 5, I got 19, and 19 and -6 is 13. We're going to take what you've just learned and move it just a couple baby steps further into two-step equations. The thing you have to remember about two-step equations is that there's more to deal with than just one step. I think of this as like unwrapping a package. My package is X. I need to get X all by itself. So the first thing I do is I take off the bow, then I take off the wrapping paper. Addition and subtraction is undone before multiplication and division. It's kind of like PEMDAS in reverse. I'm going to do example 2 with you because I see a fraction there and I know how fond you all are of fractions. My first step is going to be to add 6 to both sides and I will get 3/4 x equals 21. Now technically I've said if x is being multiplied by a number, we want to divide by that number. But remember that division of fractions is really the same as, drumroll please, multiplying by the reciprocal. So rather than do this, I'd prefer to make it a little less messy and multiply both sides by 4/3. Once I do that, multiplicative inverse is going to give me a 1x or an x on the left, and I can cross cancel here, 3 into 21 7 times and get 28. Let's see how this will check. I'm going to plug in 28 into the original equation, multiply that by 3/4, subtract 6, and ask the question, does it equal 15? 4 goes into 28 7 times. 21 minus 6. Does that equal 15? Sure, it does. Let's take a look at number 4, and I'll leave the odds here for you to work on. Again, the first thing I want to deal with is the 2. So I'm going to subtract 2 from both sides, leaving me with u over 5 equals -2. U is being divided by 5, so I'm going to multiply it by 5, and I'm going to put the 5 over a 1 just to make it easier on the left. I'm going to cancel my 5's and get a 1u, or a plain old u, equals -2 times 5, which is -10. To check that answer, I'll plug it in to my original equation, so -10 over 5 plus 2. Does that equal 0? Does negative 2 plus 2 equal 0? Yes, we know by the additive inverse property that that would be true. Let's do a few more practice problems, especially those that contain some fractions. So number 2 here, the first thing I'm going to do is I'm going to add 6 to both sides. You have to add 6 to 2/3. I get negative 1/3 y equals 6 2/3. But eventually I have to make that improper because I need to multiply on the left by negative 3 over 1 to give me the multiplicative identity there of 1. So I multiply by the inverse of negative 3 over 1. So I'm going to multiply this side by negative 3 over 1. I would get y on the left. 6 2/3 is the same as 20/3 times negative 3 over 1 is going to give me negative 20. Now to check that, negative 1/3 times 20, and I can put that over 1, minus 6, does that equal 2/3? And remember, that's the question I'm asking. So that's going to give me negative 20/3 minus 6. Does that equal 2/3? And I forgot to plug in here. Sorry guys, that's a negative 20. That should be a positive 20/3. Well, 6 is really 18/3, so 20/3 minus 18/3 does give me 2/3. Number 4. The first thing I want to do is add 5. So I get n over 2 equals 12. I'm going to multiply both sides of the equation by 2 over 1, and that's going to give me n equals 24. Is 24 divided by 2 minus 5 equal to 7? Well, is 12 minus 5 equal to 7? Yes, 7 equals 7. 6. Keep in mind I want to get n alone, so I'm going to take care of the things that are farthest away from n first. So that means I'm going to add this 15 to both sides. I get 9 equals negative 3n. Divide both sides by negative 3, which will give me n equals negative 3. To check that, does negative 6 equal negative 3 times negative 3 minus 15? Does negative 6 equal 9 minus 15? Yes, negative 6 equals negative 6. It checks. I'm going to take a look at number 8 for the last problem. The first thing I'm going to do is add 2 to both sides. I get n over 0.3 equals 7. And again, what's n being divided by? 0.3. So I'm just going to multiply both sides of this equation by 0.3. On the left, they cancel, and I'm left with n. And 7 times 0.3 is 2.1. Let's check it. Is 2.1 divided by 0.3 minus 2 equal to 5? Well, I think you should go down and divide the 2.1 by 0.3 and make sure you didn't make a decimal mistake. Outside, inside, up. 3 goes into 21 7 times. Is 7 minus 2 equal to 5? Yes. Great job tonight. We'll continue with more fun solving equations 1 and 2 steps tomorrow. Have a great night, everyone.